Welcome to everybody. I'm Luca Carettoni, and I work as a security consultant in Secure Network for Secure Network, which is a security company based in Milan, Italy. Today, with my colleague Claudio Merloni,
hello.
We would like to present our project and consideration about Bluetooth security. Before starting, I would like to excuse myself for my bad English. So if you don't understand something, please don't hesitate to ask me to repeat. Let's see the agenda for today. We want to start to explain where and how the project started. After that, we would like to introduce our hidden word spreading trolley, the Bluebag, and after that, we would like to present targeted attack and make an estimation of the effectiveness of this targeted attack with simulation and statistical results. Mobile computing is quickly gaining ground in our day-to-day life. For this reason, it's very important to consider all types of wireless devices, also Bluetooth-enabled devices, because Bluetooth-enabled devices are everywhere. We have mobile phone, of course, but also printers, digital camera, GPS navigator, antenna. So it's very important to consider this device, and it's very important to consider that these devices today have a similar potentiality of the normal personal computer, the normal personal computers. They have the same computational power, or very similar. They have the same data storage capability. And so they became more and more useful for people, but also more vulnerable and interesting, and more interesting for potential attackers. Before we started our project, we weren't able to find any data about the spreading of the technology. We weren't able to find any data about the the types of devices present in different contexts. We were interested in airport stations, university campus, and so on. We weren't able to find data about the visibility time of the devices, so the time in which an aggressor could exploit a device, and also the different types and models of devices present in our country. Our purpose is therefore to retrieve this information, and we built the Bluebag and evaluate the risk posed by exposure to worms and human aggressor. I think it's important to consider that speaking about Bluetooth devices survey means considering a reliable statistical sample, and we don't think about just simple tests made by your own PDA. Probably everyone in this room knows about the key characteristics of the technology. I summarize just the most important. Bluetooth technology is technology replacement of the other old standards, like the infrared, to connect and to exchange information between different devices. The most common devices present today implement the code specification 2.0 from the Bluetooth special group interest. It's defined as an hardware. It's defined as an hardware-based radio system with a software stack. Bluetooth works near the 2.4 GHz frequency into the industrial, scientific, and medical band. Like Wi-Fi, it uses frequency hopping speed spectrum, so frequency hopping to avoid the collision. Yeah, to avoid the collision. So the Bluetooth devices make jump, so ops into 1,600 ops for a second on 79 channels. Bluetooth is primarily designed for a low power consumption device with a short operative range, 1 meter for the Class C devices and 100 meters for the Class A devices. Now that we've shown briefly the technology overview, I think it's quite interesting to introduce and to examine and compare the natural evolution of the standard, so the timeline of the specifications, with the vulnerabilities discovered by the expert and published in the full disclosure list. In 2003, EdStake published the tool RedFang, which is unusable in real-life context, but it has demonstrated that it's possible to find an hidden device doing a brute force guess on its address. In the same year, the Trifinite group revealed the Blue Snarf vulnerability, which is a vulnerability that permits to steal data from mobile phones, for example, address book, with a simple unauthenticated OBX request. The next year, in 2004, the same Trifinite group revealed the Blue Bug. The Blue Bug is quite famous, and it permits to the remote controlling of devices. Here in BlackHat, the Trifinite group shown the tool Bluever, which implements Blue Bug and other attacks. And recently, everyone has read about the Toshiba devices denial service, so another flaw in the Bluetooth stack. All of these flaws are related to error in the implementation of the stack and not design error. And this flow demonstrates how in many cases it's possible to steal information, connecting to internet, sending messages, other bad things. With Trifinite guys, we have now there is Martin over showed us and explain to everyone a lot of interesting things, a lot of interesting acts. So we want to say thank you to Trifinite guys. Now we want to focus on how could an aggressor exploit existing knowledge and vulnerabilities to realize and to pose and target attack. I think it's important to consider that vulnerability is very different from risk, because we need to consider other external factors besides the specific system failure. If we know about a mobile phone vulnerability, but we don't have this type of phone in our range, or maybe if we haven't enough time to exploit the phone due to a particular environment, I think we don't have a risk. We have a vulnerability, but we don't have the risk. So we want to focalize to this data, the data related to external to the vulnerability, but related to the potential risk. So the data collected with our instrument, we develop models and simulation try to explain these aspects. To retrieve this data, and so we speak about a reliable statistical sample, we built the Blue Bag. The Blue Bag is a hardware device. It's a trolley, and we build a mini PC into a trolley with for a lot of interesting things. We were interested in train station, airports, university campus, shopping mall. We needed a Linux-based system embedded with many Bluetooth dongles to analyze in parallel many Bluetooth devices. We had an omnidirectional antenna to improve the range of a survey. And so we built a tool to make wide area survey activities. Why a bag? Because it's not comfortable to go around with a notebook full of Bluetooth dongles. Maybe add an antenna, add an optional battery to improve power autonomy. So we needed a hidden tool, but also an easy carrying tool, an easy carrying instrument. Of course, you cannot go around with your notebook and play, maybe in crowded places, without making the curiosity of the people. So we decided that we needed a tool without human interaction. For this reason, we think that the Blue Bag is a perfect tool for long session, and that's why, that session could be long, and very long session. To fulfill this requirement, we built the Blue Bag with some specific components. We use a VIA API Mini ITX motherboard. It is 600 megahertz fanless. We use an iPod hard drive, 1.8 inch, because it's small. It's very small hard drive, and it can support acceleration up to 3G. So it's perfect to carry around. We use 8 class 1 Bluetooth dongles and another one, a Linksys modded Bluetooth dongle with an omnidirectional antenna, a 5 dBA gain antenna. For power supply, we use the smallest snap-in power supply, 12-volt power supply with 96% of efficiency. So, to improve to reduce the power consumption of our tool. After some tests, we used the Blue Bag for more than 10 hours. Yeah. Speaking about software, we use, of course, a GNU Linux system, a Gen 2 OS, with a series, with a 2.6 series kernel, using, of course, the BlueZ subsystem, so the official Bluetooth stack implementation. And we developed a custom Python software, which will be explained by Claudio.
Hello. I'll summarize the characteristics of the Python software we developed. It's clearly a multi-threaded software because we need to exploit all